All right, everybody. Welcome to Zoology. This is going to be the first video in the Introductory to Zoology video series. Today we're going to talk about taxonomy and the naming of different species. We're going to talk about what zoology is, what zoology means. And we're going to talk a little bit about the driving force behind the shaping of species on our planet, and that is a little something called natural selection. And we're going to talk a little bit about the guy who came up with the idea of natural selection. All right. So with that being said, let's go ahead and jump into the notes and get started. All right, everybody, welcome to the beginning of Lesson 1. This is the first in the video series on the Introduction to Zoology. So first, we're going to talk a little bit about taxonomy and the major animal phyla in this lesson. All right, the importance of taxonomy. Okay, first of all, what is taxonomy? Taxonomy is the science of naming, all right? And that is classifying, discovering, classifying, describing living things. Okay, so the big question is why do we do this? If you think about it, there are lots of things in your life that are classified, okay? Some of the classic examples that I use are your clothes. Okay. Hopefully you don't just throw all of your clothes into a big pile in your room or just throw them all into your closet. You probably have your own system of organization when it comes to your clothes. So everything you wear is considered clothing. And somewhere in your room, I'm sure you have a place where you keep your socks. And there's probably a place where you keep a drawer, for example, where you keep your shorts, your gym shorts. And then you probably have nicer shorts, shorts that have pockets or something. Then you have an underwear drawer. And then in your closet, you probably have your button-up shirts hanging up. And then in your dresser, you have T-shirts and you have your, whatever. You organize your clothing in a certain way. Another example that I use is the grocery store. Think about how ridiculous it would be to go shopping for groceries if nothing in the store was organized. So imagine if the stock guy, when he got a shipment of Cheerios, if he just wheeled the crate of Cheerios and the first open spot he found on the shelf was where he put Cheerios. So you would go down an aisle and you would find the box of cereal next to bags of rice, next to cans of green beans, next to frozen vegetables or eggs or cheese. It would take you forever to do grocery shopping. The store's organized. You go down, this aisle is canned vegetables, it's canned goods. And so everything in that aisle is all canned goods, and they're organized by the type of vegetable. So it makes things easier. So we do the same thing with living things. We classify them based on their relationships with other animals. Are they more closely related? So, for example, we have all of the cats are in a group of all cats. And there are about 28 different species of cats, I think. And so all of them are in the cat family. Now, cats are somewhat related to dogs and bears because they're carnivores, they're predators, they're meat eaters. But a bear is definitely different than, a grizzly bear, even though it is a meat eater, is different than an African lion, right? Because they're slightly different. All animals and all carnivores, but a bear's not a cat and a cat's not a bear. So that's how we group and use taxonomy to classify living things. So, for example, as I just mentioned, your clothes and the shelves at the grocery store. So, who came up with this naming system, the system of classifying things that we have? Well, that's a good question. I'm glad you asked. So, originally, there was a man by the name of Socrates. If you've ever had philosophy, you probably recognize that name. He was a Greek philosopher, and he started using Latin. He started to name living things. And his method was to just simply describe the animal based on its characteristics. And when they found a new animal that was similar to one that they've already described, they would just add another word to the name. And that got to be quite cumbersome. I think at one point in that old naming system, the honeybee had a scientific name, a species name that was, I believe, 11 words long. So you wouldn't just say the European honeybee would be its common name. You would have this huge, very cumbersome name that was it just became ridiculous. So this man, who is named Carlos Linnaeus, which he actually changed his name to a Latin sounding name. His given name was Carl von Linné. He was the one who came up with our current naming system. And that naming system is known as binomial nomenclature. And that simply means that there is a species name that only contains two words. And that is what binomial nomenclature means. So it is a name of two. Bi means two. Nomial is name. And then nomenclature is the act of giving it a name. So it's a two-word naming system. Here are the rules to the binomial nomenclature. So number one, it must be in Latin. All right, we have to ask ourselves, why Latin? Well, if I were to give you a ticket, an airline ticket, and I would say fly to anywhere in the world, fly to the country where Latin is their native tongue, that would be an airline ticket to nowhere, because the last group of people that spoke in Latin were living at the base of Mount Vesuvius when it erupted and killed all of them. So nobody speaks Latin anymore. Vatican City, the Catholic Church, that's about the closest you can get to places that still speak Latin. So the reason it is done in Latin, number one, is a lot of languages have a lot of Latin derivatives. There's a lot of Latin in your Spanish and French and English. So there are some similarities. But since it is not spoken by anyone anymore, we don't have to worry about those words, the meaning of those words changing or adding words to the language, because as English, there are words that used to mean certain things and now they have new meanings. But Latin is not spoken by anyone anymore, so we don't have to worry about those words changing. When you write a scientific name, it must be either written in italics, as I have here, or if you're handwriting it and you can't click the old italics tab, then you simply underline the word. So the species name is either written in italics and is underlined. All of the levels of names must be capitalized except for the second word in a species name. So, for example, here are a couple species. Felis concolor. Okay, this is the species name. This is the Felis concolor is the mountain lion or the puma or cougar, and its scientific name is Felis concolor, which means cat of one color. The human being, our scientific name is Homo sapien, means upright walking smart man. This, one of my favorite animals, as we know because of my introductory PowerPoint, is Otocoleus virginianus. That's the white-tailed deer. So notice two words, Otocoleus, which I don't know what that means, and virginianus means it was first discovered in Virginia, and you can see it has been Latinized, but the second word is not capitalized. And then our good old mascot, the wolf, is Canis lupus. Canis is the group of dogs, and lupus is in reference to the moon, Luna, the moon. And it got its name because they thought originally that the wolf howled at the moon. It was actually howling at other wolves, but that's what they used to always say, is it howled at the moon. So that's what its name, how its name originated. What is currently believed to be the driving force behind the evolution of species on planet Earth? That is something called natural selection, or what is commonly referred to as survival of the fittest. Okay. Now, does anyone know who came up with natural selection as being the driving force behind evolution? So hopefully many of you are saying to yourselves, I'm pretty sure that guy was named Charles Darwin. And that is correct. Darwin is the one who came up with natural selection. Now, let's talk a little bit about Darwin. All right, I want to take a break a minute from the PowerPoint, and I want to talk about something that I commonly hear when we talk about Charles Darwin. Most of the time when I ask, who was Darwin and what did he do, a lot of people come up and say, oh, isn't he the guy who came up with evolution? And that's technically not true. The idea that evolution, or the slow, gradual change of species over time, that idea had been around for many, many, many years. The issue with it, or the difference, is people had different ideas on how species evolved. Scientists were pretty certain that animals have evolved and changed over long periods of time, but what caused the change was in question. Now, let me give you an example. There was a guy by the name of Lamarck, and his theory as to how species evolved over time, or why species evolved over time, was called the idea of acquired characteristics, or the inheritance of acquired characteristics. And he said that animals over the course of their life would strive to become better and more fit in their environment. And when they reached that level of fitness, they would have offspring, and then they would pass that change onto their offspring. So his example was the giraffe. So the giraffe would stretch its neck over its lifetime to try to reach up high and eat the leaves in the tall acacia trees. And once that giraffe stretched its neck out, when it had babies, those babies would be born with long necks automatically, and that's how it happened. Now, this was hundreds of years ago, and this was long before people understood what DNA and genetics were about. So they were just trying to come up with answers to these questions. And for the longest time, people thought that well, that makes sense. Yeah, giraffe stretched its neck out, and it had babies with long necks. So if that were the case, any change that you would make to your body would automatically then be passed on to your offspring. So according to Lamarck, if you have a tattoo, then that's an acquired characteristic. You are now inked up and you have a tattoo, and that means your babies would be born with that tattoo. If you worked out and you drastically increased your muscle mass, then that means if you did that prior to becoming a parent, then that means your offspring would automatically be large and muscular. And that's what we know about DNA and genetics today. That's just not the case. So what Darwin said was, you've got all of these animals in a population, and they're different. Some of them are faster than others. Some of them have better camouflage. Some of them can fly a little better. Um, some have feathers that make them more appealing to the opposite sex. Um, the predators in these predators, their teeth are a little longer, or their paws are softer, so they can sneak easier. All of these differences make them fit for their environment, and the ones who are the most fit survive. The ones who are the least fit die. And if you're dead, you're not going to make any new members of your species. But if you survive and you pass those traits on through sexual reproduction, which is going to allow the genes to blend and cause even more variation, that if you do that over hundreds and thousands of generations, slowly and slowly those changes accumulate and that species changes over time. All right, so that's the little caveat from the difference between saying Darwin came up with evolution. He didn't come up with evolution. He came up with the idea that causes evolution to happen. So the idea that species evolved over time had been around long before Darwin. It's just he came up with the best idea to describe how evolution takes place. All right, hope that clears things up. So here's Charles Darwin. He is credited with coming up with today's explanation for why and how species evolve on this planet. It is referred to, again, as survival of the fittest. For species to apply to natural selection, there are 5 characteristics, and there are 5 conditions. Number 1, there must be a large population. So I don't know what the magic number is, but there needs to be thousands and thousands of these animals that to be considered a large population. Now, again, it's going to determine on what kind of animal we're talking about, because as you work your way up the food chain, your larger predators are widely spread, and so a population of grizzly bear is going to be nowhere near as large as, say, caribou that live up in the same region. All right, so it all depends on the species. There has to be variation, genetic variation in a population. There has to be some differences. If all of the organisms are genetically identical, then there's no room for any change. Members of the population must be able to interbreed, which means there has to be some sexual reproduction. Number 4, there has to be competition within the population. Competition for resources such as food, water, basic habitat, space. They have to be able to compete over these things. If all animals had all the space they need, all the food they needed, and all of the water that they needed, then there would be no driving force to natural selection. There has to be predation, which means animals are going to have to either A, be preyed upon, or B, are going to have to prey upon other animals, be the predator. And we have to have sexual reproduction. Number 5, there must be more offspring produced than can possibly survive. And I know this sounds terrible, but just about every living thing on the planet produces way more babies than can possibly survive. Now, there are lots and lots of examples. You look at sea turtles, and most of the babies never make it to the water. Alligators, there'll be a nest of 50 to 60 eggs. Maybe 10% of the baby alligators survive. One, again, we'll go back to one of my favorite local animals, the old white-tailed deer. Less than half of all of the male fawns born every year do not survive to see their first birthday. So life is tough on living things out there in the wilderness. It's not what you see on Bambi. The skunk and the baby deer and the rabbits and everything. They don't all live together and have fun and talk and dance and tell jokes and all that stuff. No, it is a cutthroat, horrifically brutal lifestyle that it is life and death every day out there in the wild. So I'm going to close with this question. Does the population of humans meet all of these categories? All right. Large population, definitely. Is there variation? Yes, without a doubt. But let's think about the other categories. Do we reproduce? Definitely do. But do we have competition? Do we have to compete for food? Do we have to compete for territory, for property, for space? There's my bird clock. That's the mourning dove, by the way. So these are questions, do you have to compete for food? Do you have to fight another human being to eat every day? Do you have to go out and physically kill something to eat every day? This is the kind of competition we're talking about. So really, human beings, in my opinion, do not totally fall under the guidelines of natural selection. There are aspects that we really, especially in this country, that we really don't have to worry about. A competition for food is not that big of a deal. Let's just go back a few months when, the old COVID hit and we had to shut everything down. What was one of the biggest things that was flying off the shelves and people were worried about getting was toilet paper? How can we say that we are competing for food when toilet paper was a hot commodity a few months ago? Not canned goods, not clean water, toilet paper. I mean, that was one of the big issues that we had to face was, can we get clean toilet paper? Just that right there, I think, speaks volumes about how we really don't have to compete for food. Okay, so think about that as we wrap things up today. All right, that should bring us to a good stopping point for the first lesson on the video series. So go ahead and exit out of YouTube here. Head on over to Schoology and take your exit slip for lesson 1 of the video series on Introductory to Zoology. Thanks, and we'll talk to you later.